Good afternoon, my dear friends. Today we will discuss inventory model, which is the part of project management and operation research. Today we will discuss these points throughout this presentation. Inventory means physical stock of items or goods which is maintained at our warehouses for satisfying the future demands. Our inventory control is the measure to ensure that appropriate amounts of raw materials. Here we will estimate optimum amounts of quantities which is to be maintained at our warehouses. Some basic inventory decisions or some process will be there in our mind. How much to order, when to order, how much cost is required for that particular order, and how much safety stock we should maintain at our warehouse. These are the some applications in various industries. Raw materials for producing final components in automotive or aerospace industries. Spare parts are to be maintained for repairing and maintenance. Consumables and cleaning materials are to be maintained for doing repairing and maintenance of plants and machineries and other areas of the industry. Chemical and glasswares are needed in chemical industries for testing laboratories. Helmets, shoes and goggles are required, needed, mandatory for the safety of the person. Why inventory is important? Our industry or organization become a competitive, or it should be continuous in operation. Here, following are the some natures of demand and supply. Here we need to understand the natures of supply and demand, how these things are getting changed with respect to time. Like these situations will be there in market: static, dynamic and probabilistic. Sometimes demand is constant with respect to time. Dynamic demand is changing with respect to time. Sometimes it is more, sometimes it is less. But in probabilistic it is totally confusing. Here difficult to estimate exact demand, difficult to find exact demand, difficult to understand exact customer need or demand. Here we will estimate only probability, probabilistic demand, how much percentage we will satisfy or how much percent demand will be there in future. These are the terminologies used in inventory model. Demand is to be calculated or it is predefined. It is not predefined. It is not predefined, but it can be estimated based on our past experience or based on our previous experience, and that will be used for next decision. Lead time is the gap between the first and last point. These points are placing order and receiving order. That is lead time. Between this time, we will order and receive that order. That is compulsory. That much duration is given for that particular order. Following are the some inventory cost components. These costs are important during the calculations of EOQ and EPQ model. Holding cost, purchase cost, ordering cost. These costs we need to pay during the maintaining stock at our warehouses. Here this is very important. Shortage stock, that cost will be incurred when an item is out of stock or zero, and that is not affordable to industry because the customer demand or some requirements are more in future. At that time our loss will be more. Opportunity cost, wherever it is required, wherever it is offered, it may be in gain or profit. At that time we will use profit cost. And this whole inventory is based on our inflation and deflation situation. There are two situations, inflation and deflation. In inflation, there are two situations, pull inflation and push inflation. Less supply and more demand. Market demand is more, but supply is less. Easily we can pull our component to the market. Here, cost of the raw material is increasing, then whole cost is getting increased. That is push inflation. Means whole costs are increasing. Here, some values, present values of the particular inventory or particular model is estimated for future cash flow. There are two types of discount rate types. Flat discount, suppose market situation is not good, not so good, at that time we will use flat discount. Their discount will be 40%, 30%, maybe 60%. In cash discount, here we will get 10%, 5% or 10% cash discount. Here, inventory control model or inventory control cycle is very important. This diagram is very important in inventory model. Here we will understand what is the exact meaning of this particular diagram. On x-axis, time, on y-axis, inventory level are defined. Here, our inventory stock will start from this point, and this data is recorded for particular time. Our stock will start from this point. At this point, stock is 0. Then we will move towards reorder point. That is our reorder point. And from this point, we can draw horizontal line. And this line is minimum inventory level which is maintained at warehouse. And that inventory is safety stock. That is minimum stock maintained at our warehouses. After that, we have to order some quantity. That quantity is Q. Order quantity, EOQ or EPQ, order quantity. Then this quantity, total quantity will be this one. This is our maximum inventory level. That much quantity is available at our warehouse. And after that, when we will receive that much quantity, we will use that stock for further need. That need will be in assembly, that need will be in sub-assembly, that need will be in work in process. We will use up to this point. At this point, we will order that quantity. That is reorder point. This point is placing order and this point is getting order. Here we will receive order, and between these 2 points, that lead time. Between these 2 points, lead time is defined. Within this lead time, we will order and we will receive order. That is compulsory. When we will receive this order, then our stock will be this much. After that, again we will use this same up to this point. Again we will order, then we will receive order, then stock will be this much. Again we will use order, then we will receive order here. Similarly, we will follow this path. These are the assumptions we have to follow during this model, during this situation. And these assumptions will be used during problems. This is EOQ cost model. These are the costs. These are the costs calculated or used for the estimation of optimum quantity which is to be maintained at our warehouse. Here we can understand ordering quantity plus annual cost. Here carrying cost is this much and ordering cost is this much. Carrying cost is at our warehouses we are maintaining some inventories, we are maintaining some stocks. For that maintaining or for that stock we are paying some cost, that is carrying cost. And with respect to this carrying cost, ordering cost is reducing. Or if you are ordered this cost, carrying cost is increasing. Means we are paying some amount for maintaining that stock. And addition of these two is total cost. That is graph or EOQ cost model. Here we will use these formulas for the calculation of optimum cost or EOQ or Q op. This is the EOQ formula or Q optimum, square root of 2 star or 2 into CO, that is ordering cost, into annual demand divided by carrying cost. And this is our first problem. ABC Corporation has got a demand of particular part is 10,000 units per year. Per unit cost is given. Then ordering cost is also given. Then inventory carrying cost is to be estimated at 9% of cost per unit. And these are the things to be calculated by using this data. Given data is annual demand is given 10,000 per annum, ordering cost 36 per annum, and cost per unit is given 2 rupees. Inventory carrying cost is 9% of cost per unit. Cost per unit is 2, that is 0.18 per unit. Here we can use Q opt equal to square root of we can put these values in this equation, then you will get 2000 units. Then optimum number of orders, that is second one which is asked in problem. Second one, optimum number of orders equal to D by Q opt, which is calculated here. D is annual demand divided by Q opt, that is 5. Here we will place 5 orders per annum. Third one is total cost. It should be minimum. Minimum total cost equal to, it is the addition of these two. It is addition of these two equal to RS 360. That is first problem. Second one, XYZ Corporation currently practices the following system for the procurement of an item. These are the things given. By using these things, we will calculate the given data. Annual demand 250 into 8. Each time order quantity 8 time number of orders, that is number of orders placed in a year 8, but each time we are placing 250 into 8, that is annual demand. Ordering cost is 750. Cost per unit is RS 40. Inventory carrying cost is 40% of per unit cost, that is 16 per unit. Next we can calculate first one, Q opt, square root of 2 into 750 into 2000 divided by 16, that is 433. Total cost we can use that last formula. Here we will get this value. Third one is total inventory cost under present system. By using this formula we can calculate RS 8000. Then fourth one is loss to the company is not operating scientific inventory policy. If they are following scientific inventory or not, that we can estimate by using this formula, 8000 minus this one. Here we will get 1071.8. And similarly we will do some calculations for EPQ model or EOQ model, production or economic production quantity. Here difference is 1 minus D by P. Here I have written some formulas. Then quantity discount can be calculated by using this, only change is that P into D. Then D order point can be calculated by using this formula. And a major difference between this EPQ model. And these are the references I have used for this presentation, and you can use these references for your further study. And thank you.